what is an AI first company to you? Like, so when a startup pitches you, how do you decide which company fits in this mold of AI? Like, what are your qualifying criteria? If you can share some of those.
Yeah, it's a company that fundamentally develops a competitive advantage through that. They may have a brand, they may have a sort of side network effect going on, they may have something else, they may have a patent around something. So they may have other ways to enjoy a competitive advantage in their market, but really where they're putting all their time and money is in developing a competitive advantage through data. And that's where I focus my efforts and I focus my time understanding is companies that build a competitive advantage through data. As in, the reason customers choose you, the reason they pay more for your product is because you offer such a significantly higher degree of predictive accuracy or automation than the competition.
Interesting. And you talked about data learning effects. Walk us through what data learning effect is. I'm curious. Like, what's your perspective?
So a data learning effect is the automatic compounding of information. And so three important words there: automatic, compounding, and information. So let's work back and go through the three parts of a data learning effect. So firstly, you need a critical mass of data. In some cases, this could be a very large amount of data. For example, if you're trying to recognize something in an image, you need lots of examples of it for a machine to be able to learn from it. Or it could be a very small amount of data. But the point is you need a critical mass of data so that, two, you can process it into information. You use techniques to clean the data, label the data, etc., to turn data, sort of ones and zeros, binary values, categorical values, into information, a picture of what you're looking at, of the customer you're looking at, of the system you're trying to model. And then thirdly, you need a network of models that can learn from that information. So they're interconnected. They see a bit of information, correlate it with another bit of information, form a conclusion, pass it on to the next model that then takes the output of that and something else, does a derivation, learns something from that, passes it on to the next one. And so you've got three things: a critical mass of data, capabilities to process that data into information, and a network of models that can learn from that information. And so the first part is sort of big data, so to speak. The second part is analytics. And the third part is machine learning, mostly, not always. And you need all three of these things to get this loop going. And this loop being the way that ideally automatically compounds information. So the loop being, you gather data from the real world, you process it, you make a prediction, and you see how that plays out in the real world, and you learn from it. Was that prediction right or wrong? And if it's right, then you reinforce that loop. Next time you go around, you do the same thing again. If it's wrong, you adjust it. And then hopefully next time it's better. So it's automatically going through these cycles every so often, and it's compounding in value when it's right. It's getting better and better, or it's learning from what it's observing in the real world. So that's what a data learning effect is. And again, you need all three parts of that. It's not just about having scale to data. And it's not just about having some sort of network effect. It's not just about having capabilities around data processing. It's all of those things.
Interesting. And one I was thought I was when you were saying this, I was thinking about that. So when you say normal persona about AI that people have is, hey, AI will decide something on my behalf and take a decision. So say if you're an AI first company, you build yourself to take decisive action quickly and sort of
Yeah.
beat your competition to it. How do you decide what are some of like which predictions to pursue? Like, how do you figure out um, what are good
It's a very
decision
good
versus bad?
question.
Yeah.
Yeah, it's a very good question. It goes back to what we were sort of touching on before, but didn't go into. So I'm glad you followed up with this one. What's the payoff is one question. Is it going to be the case that when the prediction's right, you get something really valuable, but when it's wrong, it's really costly. So consider the sort of payoff. Two, what's the potential for drift? Is in, these models train on a set of data that is collected from the real world. But is the real world, the environment in which you're operating, changing so quickly that the data that you've got to train the model actually won't represent the real world in 35 seconds or 35 microseconds, like in financial markets? And so if there's really high potential for drift there, then it might not be a good AI problem, because you're going to have to gather data and retrain so quickly that you won't be able to keep up. So there's certain ways in which we sort of understand how these models work that inform whether or not they'll be applicable to a certain problem. And I have a whole checklist in the book, a series of questions that say, okay, is it this or is it that? Is there high potential for drift, low potential for drift, etc.? Is there high demand for variety? Is there a reason to have a model spitting out lots and lots of options for customers when they go to a website to buy something, lots of recommendations? Or is that not really valuable, in which case you can just have a human curating one thing for people to buy? If there's high demand for variety, it's a good problem for an AI-based recommender system. If there's low demand for variety, it's not. You may as well just use a human curator, as I said. So I've got a whole list of questions that sort of help you work through if something is a good prediction problem, and that's a sample from that list.